Welcome to Fictional Scientist. After this video, reality will never feel the same again. Imagine being a fish, living your entire life underwater, and then one day the water starts to disappear. The pond is drying up, you're suffocating, and you have two choices: stay and die, or try something impossible. Crawl onto land, breathe air, become something new. Tonight we're going to watch that transformation, from fish to amphibian, from amphibian to reptile, from reptile to mammal, from mammal to you. Close your eyes if you'd like. Let your breathing settle. There's no rush here, no urgency, just a story. A long, slow story about ancestors, about transformation, about the journey that led to this moment. You are the product of an unbroken line, stretching back through time, through millions of generations, through countless bodies, each one slightly different from the last. Each one adapting, surviving, passing something forward. And tonight we're going to trace that line all the way back to the water, to fins, to gills, to the moment when your ancestors faced an impossible choice and chose to walk. Right now you can feel air move in and out of your lungs. That feels ordinary, automatic, but it's a biological miracle built on ancient machinery, because breathing air is not the default for vertebrates. The original design was water, dissolved oxygen. Gills, a constant flow. To leave water is to change physics and chemistry at the same time. In water, buoyancy carries your weight. In air, gravity arrives fully. In water, temperature shifts slowly. On land, heat spikes and drops fast. In water, your skin can be permeable. On land, it becomes a liability because water evaporates and dehydration becomes a silent predator. So when we say a fish crawled onto land, we're not describing a cute evolutionary curiosity. We're describing an organism stepping into an entirely different set of rules. A different world of oxygen availability, mechanical load, UV exposure, and desiccation. And the only reason this happened is because a few fish already had the beginnings of a solution. Pre-adaptations that were useful in water and unexpectedly useful on land. Evolution doesn't plan, it repurposes. Let's go back, way back, to a time so distant it doesn't feel real anymore, 375 million years ago, the Devonian period, the age of fishes. The Devonian wasn't just a long time ago, it was a world with different coastlines, different climates, and different atmospheric dynamics. Sea levels fluctuated, shallow coastal plains formed and vanished. Rivers braided into floodplains, leaving behind isolated pools that could become oxygen poor as they warmed. Warm water holds less dissolved oxygen than cold water, and stagnant water, especially if it's full of decaying plant material, can become hypoxic, low in oxygen, fast. In such pools, a fish can suffocate even while still submerged, simply because there isn't enough oxygen dissolved to extract through gills. This is the crucial point. For some fish, the crisis wasn't only no water, it was also bad water. And that's where air gulping becomes a survival hack. Earth was a different place. The continents were arranged differently. Pangaea hadn't formed yet. The land masses were scattered, separated by vast oceans. And those oceans were full of life. Fish everywhere, thousands of species, jawless fish, armored fish, cartilaginous fish, bony fish. They filled every niche, every depth, every temperature. The oceans belonged to them. Some were small, finger-length, darting through coral reefs. Others were enormous. Predators longer than a school bus, with plated armor and crushing jaws. The Devonian was the age when fish dominated, when they were the most successful, most diverse, most powerful animals on the planet. And on land, almost nothing. No forests, no animals, just bare rock and primitive plants, mosses, ferns, early trees that looked nothing like modern trees. The land was quiet, empty, harsh. Why would anything leave the water? Water was safe. Water had food. Water supported your weight, made movement easy, provided everything you needed to survive. But something was changing, and some fish were about to face a crisis. Imagine floating in warm, shallow water. The sun filters down through the surface, creating patterns of light and shadow on the muddy bottom. You can feel the water supporting you, holding you. You don't have to work to stay upright. The water does it for you. Around you, other fish drift, hunting, hiding, living their lives. This is home. This has always been home for millions of years, for hundreds of millions of years. But the water level is dropping slowly, imperceptibly at first. The rains aren't coming as often. The pond is shrinking, getting shallower, warmer, and soon there won't be enough water left. The Devonian climate was unstable, wet seasons, dry seasons. Some years the rains were abundant, rivers swelled, ponds filled, life thrived. Other years the rains failed, rivers shrank to streams, streams shrank to puddles, and ponds, the isolated bodies of water where many fish lived, began to evaporate. This was a death sentence for most fish. When the water disappeared, they died, suffocated, stranded, their bodies left to bake in the sun. But some fish had an advantage, a small one, a strange adaptation that most species didn't have: lungs. In fact, lungs didn't appear out of nowhere. Many bony fish belong to lineages where an internal air-filled sac evolved early. In some groups, that sac became a swim bladder, used mainly for buoyancy control. In others, it retained or regained a respiratory function, a primitive lung. And that distinction matters because it shows how evolution works. One structure, multiple futures. An air sac that helps you float can, under different pressures, become an organ that helps you breathe. Even today, you can see echoes of this in living animals. Lungfish can breathe air directly. Some fish species can survive brief periods in oxygen-poor water by gulping air at the surface. They're not trying to become land animals. They're simply using an emergency system, exactly the kind of system that could be pushed generation by generation into something permanent. These weren't like modern lungs. They were primitive, simple sacs connected to the throat. But they could do something remarkable. They could extract oxygen from air. Not efficiently, not well, but enough to survive for a short time when the water got too warm, too stagnant, too oxygen poor. These fish would rise to the surface, gulp air, let the oxygen diffuse into their blood, and then dive back down. It was a backup system, an emergency measure for when the water wasn't enough. But now the water was disappearing completely, and gulping air at the surface wouldn't help. The pond was drying up, and if they stayed, they would die. Some fish had another adaptation, fins that were different, stronger, fleshier, with bones inside that could support weight. These fins were good for pushing through dense vegetation, for moving across muddy bottoms, for propping the body up when the water got too shallow. And now, with the pond drying, these fins might be good for something else, for crawling. Here's the moment, the impossible moment, when everything changed, when a fish, gasping in the last puddle of water, used its fins to push itself forward, onto the mud, into the air. It wasn't elegant. It wasn't graceful. The fish flopped, struggled. Its body, designed for water, was suddenly unbearably heavy. The air burned its gills, dried its skin. But the fins, those strange fleshy fins, pushed against the mud, and the fish moved, forward, inch by inch, away from the dying pond, toward another body of water, another chance. Most fish that tried this died. The distance was too far, the sun too hot, the air too harsh, but some made it, and those that made it survived, reproduced, passed on those strong fins, those primitive lungs, that ability to survive briefly on land. And over millions of years, that ability became something more, something permanent, a new way of life. We know this happened because we found the fossils, the evidence, the bodies preserved in stone. And one of the most important fossils ever discovered is called Tiktaalik. Tiktaalik lived about 375 million years ago in shallow streams in what is now Arctic Canada. Back then, it was a warm, tropical environment, full of water and full of fish trying to survive the seasonal droughts. Tiktaalik was about 6 feet long, with a flat, crocodile-like head, sharp teeth, and scales covering its body. In many ways, it looked like a fish. That flattened head is not just aesthetics, it's mechanics and behavior. A fish with a high, narrow head is streamlined for constant swimming, but in shallow water, where the bottom is close and the surface is right above, you benefit from a head that can lift, pivot, and look into a new environment. Tiktaalik also had something extremely significant: a functional neck. Most fish effectively have no neck. Their head is fused to the shoulder region. Tiktaalik shows a separation, allowing the head to move independently from the body. That means it could raise its snout above the surface and turn, an early preview of land-based sensing. It also had strengthened ribs. In water, the body is supported by buoyancy. On land, even briefly, the chest can collapse under its own weight unless reinforced. Stronger ribs help support the body and protect internal organs when bracing on the substrate. This is the hidden theme. Leaving water is not one change. It is many changes that must cooperate. But in other ways, it was different. Very different. Its fins weren't just fins. They had bones inside: shoulder bones, elbow bones, wrist bones, the same bones you have in your arms, arranged differently, but recognizable. Tiktaalik could do something most fish couldn't. It could do push-ups. It could prop itself up on its front fins, lift its head out of the water, look around. It still had gills. It still lived in water, but it could breathe air. It could move on land, clumsily, awkwardly, but it could do it. Tiktaalik is what scientists call a transitional fossil, a creature caught between two worlds. Not quite a fish, not quite a land animal, something in between. And it's one of your direct ancestors. The bones in your arms, the bones you're resting on right now, are modified versions of Tiktaalik's fins. The same structure, the same inheritance, just changed, adapted, refined over millions of years. You have fins. You've always had fins. They just don't look like fins anymore. Lift your hand, slowly look at it, or just imagine it if your eyes are closed. 5 fingers, a palm, a wrist, an arm. Now imagine those bones as fins. Imagine them covered in scales instead of skin. Imagine them pushing through water instead of air. This isn't metaphor, this isn't poetry. This is anatomy, this is history. Your arm is a modified fin. The structure is the same. 1 bone in the upper arm, 2 in the forearm, a cluster of small bones in the wrist, and digits extending outward. Fish have this pattern. Amphibians have it, reptiles have it, mammals have it, birds have it. It's called the pentadactyl limb, and it traces back to creatures like Tiktaalik. You are carrying the ocean with you. In your bones, in your body, in the structure of your arms and legs, you are still, in some deep way, a fish. After Tiktaalik, things accelerated, slowly by human standards, but rapidly in evolutionary time. Within a few million years, the descendants of fish-like creatures had become true land animals. We call them tetrapods, 4-limbed animals. And they were the first vertebrates to live primarily on land. Moving on to land creates new problems you wouldn't expect. For example, hearing. In water, sound transmits efficiently and the body can detect vibrations differently. In air, impedance changes. Sound behaves differently. Early tetrapods needed new ways to detect airborne vibrations. Over time, the middle ear evolved structures specialized for air hearing, an evolutionary remodeling of bones and tissues that originally served other roles. Breathing also changed. Gills are useless in air. Primitive lungs had to become more vascular, more efficient, and connected to a pumping system that could move air in and out. Even simple lungs demand a stable internal moisture level and a way to exchange gases without drying out. And locomotion demanded a new gait. In water, the tail is the engine. On land, you need limbs that coordinate with the spine. That reconfigures muscles, joints, and nervous control. None of this happened overnight. But each small improvement, slightly stronger joints, slightly better air exchange, slightly more coordinated steps, could mean the difference between dying in a drying pool and reaching another one. They still needed water. They still laid their eggs in water. They still had wet skin that dried out easily. But they could walk. They could breathe air continuously. They could hunt on land. These early tetrapods looked strange, like giant salamanders. with wide, flat heads, stubby legs, long tails. They weren't fast, they weren't elegant, but they worked, and they had access to something no animal had accessed before, a food source no one else was eating: insects. By the late Devonian, insects had colonized the land. Millipedes, centipedes, early dragonflies. They scuttled across the rocks, they crawled through the primitive forests, and no one was eating them until tetrapods arrived. Suddenly, there was an entire ecosystem to exploit, and the tetrapods that could exploit it thrived. They grew, diversified, spread across the continents. By the Carboniferous period, about 50 million years later, the land was full of amphibians, some small, some enormous, some longer than a crocodile, with powerful jaws and sharp teeth. This was the age of amphibians, when they dominated the land, before reptiles, before mammals, before anything else, and you are their descendant, their continuation, their future. But amphibians had a problem, a fundamental limitation. They couldn't leave the water completely because their reproduction depended on it. Amphibian eggs are soft, jelly-like. They have no shell, they dry out instantly in air. So amphibians had to return to water to breed, to lay their eggs, let their young develop. This tied them to the shoreline, to ponds, to rivers. They could wander inland, but never far, never permanently. They always had to come back. For millions of years, this was fine. The land was wet, water was everywhere, amphibians thrived, but then the climate changed again. The Carboniferous gave way to the Permian, and the world became drier, hotter, harsher. Amphibians struggled. Their wet skin dried out, their breeding sites disappeared. They retreated to the remaining waterways, to the coasts, to anywhere moisture still lingered. But some of their descendants had evolved something new, something that freed them from the water entirely. A shell, the amniotic egg. It doesn't sound revolutionary, but it was. It was one of the most important innovations in the history of life on land. An amniotic egg has a shell, hard or leathery, that protects the embryo from drying out. Inside, there are membranes. The amnion, the chorion, the allantois, each with a specific function. Together they create a self-contained environment, a private pond, a portable piece of ocean. Inside this egg, an embryo can develop completely, without ever touching water, fed by a yolk sac, protected by the shell, surrounded by fluid. And when it hatches, it emerges fully formed, ready for land. Not a tadpole that needs water, but a miniature version of the adult. This changed everything, because animals with amniotic eggs could live anywhere. Deserts, mountains, forests far from water. They weren't tied to breeding sites. They could roam, explore, colonize every habitat. The first animals to develop this egg were the reptiles, and they exploded across the planet. Within a few million years, they had diversified into hundreds of species, filling every niche, every environment. Some reptiles stayed small, lizard-sized, hunting insects, hiding under rocks. Others grew enormous, the size of cars, of buses. They became the dominant predators, the top of the food chain. And some took to the air, developing wings, gliding between trees, eventually flying. One lineage of reptiles would become dinosaurs, another would become birds, another would become the ancestors of mammals, and you are part of that last lineage, the one that led from reptiles to mammals, from cold blood to warm, from scales to fur, from laying eggs to bearing live young. But that transition took time, millions of years, and it required another series of impossible transformations. Picture a landscape, dry, rocky, the sun beats down, there's no shade, no water nearby, just bare rock and scattered scrubby plants. A small reptile emerges from a crevice. It's about the size of a rat, covered in scales, moving in short, quick bursts, stopping to scan for predators, for prey. This reptile is one of your ancestors, not directly, but part of the lineage, part of the unbroken chain that connects you to the ancient fish. It doesn't know this. It doesn't know anything about the future, about the descendants it will have, about the transformations they'll undergo. It just lives, survives, reproduces, passes something forward, and that's enough. That's always been enough. About 300 million years ago, one group of reptiles began to change, to diverge from the rest. These were the synapsids, and they were evolving towards something new, something mammalian. The changes were gradual, small, each generation slightly different from the last, but over millions of years, the accumulated changes became dramatic. Their legs moved. In most reptiles, the legs stick out sideways. The body sags between them. It's efficient for short bursts, but not for sustained movement. In synapsids, the legs began to move underneath the body, supporting it from below. This allowed for a more upright posture, more efficient walking, more endurance. Their jaws changed. In reptiles, the jaw is made of several bones. In mammals, most of those bones have migrated to the ear, becoming the tiny bones that transmit sound. In synapsids, this migration was beginning. The jaw was simplifying. The ear was becoming more complex. Their teeth changed. Reptiles have uniform teeth, all the same shape, good for gripping, not good for processing food. Synapsids developed differentiated teeth, incisors for cutting, canines for tearing, molars for grinding. This allowed them to chew, to break down food before swallowing, to extract more nutrition from each meal. And most importantly, their metabolism changed. Reptiles are ectothermic, cold-blooded. They rely on external heat. They bask in the sun to warm up. They're sluggish in the cold. Synapsids were evolving toward endothermy, warm-bloodedness, the ability to generate heat internally, to maintain a constant body temperature. This was expensive, it required a lot of food, a lot of energy, but it had advantages. You could be active at night, in cold weather, in places reptiles couldn't go. By the late Permian, some synapsids looked almost mammalian. They had fur, they had differentiated teeth, they were warm-blooded, they cared for their young. They weren't quite mammals, but they were close, very close. And then disaster struck. 252 million years ago, something catastrophic happened. The worst mass extinction in Earth's history, the Permian-Triassic extinction event. Scientists don't know exactly what caused it. Massive volcanic eruptions, climate change, ocean acidification, possibly all of the above. But the result was clear. Over 90% of all species went extinct. The oceans died, the land died, entire ecosystems collapsed. The synapsids, the mammal-like reptiles, were devastated. Most lineages went extinct. The survivors were small, marginalized, pushed to the edges, and into that empty world came a new group, the dinosaurs. For the next 180 million years, dinosaurs dominated. They filled every niche, every size, every habitat. They were the largest land animals that ever lived, the most diverse, the most successful. And the mammals, the descendants of the synapsids, they survived, but barely. They stayed small, nocturnal, hidden, living in the shadows, in burrows, in trees, anywhere the dinosaurs weren't. For 180 million years, mammals remained small, no larger than a cat, most smaller, shrew-sized, mouse-sized. But they were adapting, evolving, waiting. And then, 66 million years ago, everything changed again. An asteroid struck Earth, in what is now the Yucatan Peninsula in Mexico. The impact released energy equivalent to billions of nuclear bombs. It vaporized rock, sent a plume of debris into the atmosphere, blocked out the sun. The world went dark, cold. Plants died, herbivores starved, carnivores starved. The food chain collapsed. Within months, most dinosaurs were dead. Within years, all non-avian dinosaurs were extinct, gone, after 180 million years of dominance. But mammals survived, the small ones, the ones that could hide underground, that could eat anything, that didn't need much food, that could tolerate cold. And when the dust settled, when the sun returned, when plants began to grow again, the world was empty. No large predators, no large herbivores, just small survivors, picking through the ruins. And mammals began to diversify, to grow, to fill the empty niches. Within a few million years, there were mammals the size of dogs, then pigs, then cows, then elephants. Mammals colonized every habitat: grasslands, forests, deserts, mountains, oceans, sky. Some returned to the water, becoming whales, dolphins, seals. Going back to the ocean their ancestors had left 375 million years earlier. Others took to the air, becoming bats, the only mammals capable of true flight. And one group took to the trees, developing grasping hands, forward-facing eyes, large brains. Primates, your lineage. You are a primate right now. As you lie here, you have the body of a primate, the hands, the eyes, the brain. These features evolved for life in trees, for climbing, for judging distances, for manipulating branches. Your hands can grasp, your opposable thumbs allow you to grip objects, to manipulate tools, to write, to create. Your eyes face forward, giving you depth perception, stereoscopic vision, the ability to judge distances accurately, essential for jumping from branch to branch. Your brain is large, proportionally larger than almost any other mammal. This allowed your ancestors to navigate complex three-dimensional environments, to remember where food was, to solve problems. You are still, in some deep way, a tree dweller, even if you never climbed trees, even if you've lived your entire life on the ground. The body remembers. For millions of years, primates lived in trees, safe from ground predators, with access to fruits, to leaves, to insects. But some primates began to spend more time on the ground. In Africa, where forests were giving way to grasslands, where food was becoming scarce in the trees. These ground-dwelling primates faced new challenges, new predators, less cover, more competition. But they had advantages too. They could cover more distance, access different food sources, and their hands, evolved for grasping branches, were equally good at manipulating objects. One lineage of these ground-dwelling primates became the hominins, the human family, and they began to change in distinctive ways. They walked upright, bipedally. This freed their hands. This allowed them to carry things, to use tools, to manipulate their environment. Their brains grew larger, much larger. This allowed for complex thought, planning, language, culture. Their social structures became more complex. They lived in groups, cooperated, shared food, cared for the young and the old. And about 2 million years ago, they began to use fire to cook food, to stay warm, to keep predators away. These changes accelerated, each innovation building on the last. Tools became more sophisticated, language became more complex, culture became more elaborate, and eventually, about 300,000 years ago, modern humans emerged, Homo sapiens. Anatomically, behaviorally, us. We spread across Africa, then out of Africa, into Asia, into Europe, into Australia, across the Bering Strait into the Americas. Within a few thousand years, we had colonized every continent except Antarctica, adapted to every environment, from deserts to tundra. From rainforests to mountains, we are the most widely distributed large land animal on the planet, found in places no other primate has ever lived. And all of this entire journey traces back through millions of ancestors, through countless bodies, through transformations so profound they seem impossible, from fish to you. You don't have to take this on faith. You don't have to trust the fossil record alone. The evidence is in your body, right now, in structures that make no sense unless you understand where they came from. You have a tailbone, a coccyx, a remnant of a tail that your distant ancestors had. Primates lost their tails as they adapted to different modes of movement, but the bones remain, fused together, serving no function, just there. A reminder, you have wisdom teeth, third molars that often don't fit in your jaw, that cause problems that need to be removed because your jaw is smaller than your ancestors. Jaws. We don't need to grind as much food, but the teeth remain. A remnant from a time when we did. You have goosebumps. When you're cold, when you're frightened, tiny muscles contract, making your hair stand up. In mammals with fur, this traps air, creates insulation, looks threatening to predators, but you have almost no body hair, so goosebumps do nothing. They're vestigial, left over from furry ancestors. You have hiccups, a spasm of the diaphragm, followed by a sudden closure of the vocal cords. It serves no function in humans, but it's identical to the breathing pattern of amphibians. When they gulp air and water, hiccups are a glitch, a leftover from ancestors who breathed differently. Your embryonic development reveals even more. Human embryos have gill slits. Briefly, in the first few weeks, they don't function as gills. They become other structures, but they're there in the same position as fish gills, following the same developmental pattern. In embryology, these are often called pharyngeal arches, structures that in fish contribute to gills, and in mammals are repurposed into parts of the jaw, neck, and ear. Same blueprint, different outcome. And about hiccups, there are multiple hypotheses for why they persist. One popular idea is that hiccups reflect ancient breathing coordination patterns, an old neural circuit that sometimes triggers by mistake. Whether or not any single hypothesis is the full story, the broader point remains. The nervous system is layered, built on older circuitry. And sometimes older circuitry shows itself in quirks that modern life doesn't really need. Your body is not designed fresh each generation. It is modified, patched, updated, like an ancient program still running inside new hardware. Human embryos have a tail, a real tail, with vertebrae for several weeks. Then it usually gets reabsorbed. The vertebrae fuse into the tailbone. But sometimes, rarely, babies are born with external tails. Proof that the developmental program is still there, still running, still building a tail, even though we don't need one. Your body is an archive, a living museum, full of evidence of ancestors, of transformations, of the long journey from water to land. You are not separate from evolution. You are evolution, ongoing, in progress. Take a breath, deep, slow. Feel the air fill your lungs, oxygen diffusing into your blood, carried to every cell. Those lungs started as simple sacs in fish, emergency organs for when the water got bad, and over hundreds of millions of years they became complex, efficient, essential. The air you're breathing is the same air those ancient fish gasped. The oxygen is the same. The process is the same, just refined, perfected, made permanent. You are breathing the way a fish breathes. When it surfaces, when it gulps air, you never stopped. You just got better at it. Let's put this journey in perspective, because the time scale is hard to grasp, hard to feel, but it's important. 375 million years ago, that's when fish started crawling onto land, when Tiktaalik lived, when your fishy ancestors first left the water. If you compress that time into a single year, with January 1st being 375 million years ago and December 31st being today, here's how it would look. Fish crawl onto land, January 1st. Amphibians dominate, February to April. Reptiles evolve, May. Dinosaurs appear late June. Dinosaurs go extinct, mid-November. Primates appear late November. Hominins start walking upright, December 30th. Modern humans appear December 31st around 11:40 p.m. All of recorded history, the last 30 seconds before midnight. Your life, your existence is happening in the final fraction of a second, the very last moment. And yet you carry all of it. All of that time, all of those ancestors, all of those transformations in your body, in your DNA, in your bones. You are not separate from this history. You are its continuation, its current expression, its living edge. But here's something important to understand. Evolution doesn't have a direction. It doesn't have a goal. It wasn't trying to create you. It wasn't aiming for humans. Fish didn't want to walk on land. Amphibians didn't want to become reptiles. Reptiles didn't want to become mammals. There was no plan, no foresight, no purpose, just organisms trying to survive in environments that were changing, making the best of whatever mutations appeared, whatever variations arose. Sometimes those variations helped, and they spread and became common, and over time accumulated into something new. Sometimes they didn't help, and they disappeared, and were forgotten. Evolution is not progress, it's not improvement, it's adaptation to whatever environment you're in, to whatever challenges you face. The fish that crawled onto land weren't advanced. They were desperate. The water was disappearing, and they had traits that allowed them to survive briefly on land. So they did. Their descendants got better at it over millions of years, through countless generations, through endless tiny changes, until eventually they didn't need water at all. Not because they were trying to leave the water, but because the ones who could survive away from water had more options, more places to live, more food sources. And so they thrived, and their descendants continued changing, continued adapting, continued becoming whatever worked in their particular environment. And one branch of that tree, one tiny lineage, led to you. Not because you're the goal, but because that's how it happened, that's how the dice rolled, that's how the mutations accumulated. You are here by chance, by luck, by the fact that none of your ancestors died before reproducing. For 375 million years, an unbroken chain of survival, of reproduction, of passing something forward. And that's remarkable, not because it was planned, but because it's so improbable. The story I've been telling isn't just based on fossils, it's based on DNA, on molecular evidence, on the code that builds bodies. Every living thing on Earth uses the same genetic code, the same language, the same mechanism for storing and transmitting information. This is strong evidence that all life shares a common ancestor, because if life arose independently multiple times, we'd expect different genetic codes, different mechanisms, different languages. But we don't see that. We see universality. We see inheritance. We see modification over time. Your DNA is similar to a chimpanzee's, about 98% identical. This is because you shared a common ancestor recently, only about 6 million years ago. Your DNA is also similar to a mouse's, about 85% identical, because you shared a common ancestor more distantly. About 75 million years ago, your DNA is even similar to a fish's, about 70% identical, because you shared a common ancestor very distantly, about 400 million years ago. These percentages match the fossil record, they match the anatomical evidence, they match the embryological evidence. Everything points to the same conclusion, the same story, the same long journey from water to land, from fish to you. And we can read that journey in the sequences of DNA, in the mutations that accumulated, in the genes that were kept, in the genes that were lost. Your genome is a book written over hundreds of millions of years, with every ancestor adding a sentence, a word, a letter. And when scientists read that book, they can see the history, they can trace the lineages, they can reconstruct the family tree of all life on Earth. And that tree shows you descending from fish, from amphibians, from reptiles, from early mammals, from primates. It's not a belief, it's not a theory in the colloquial sense. It's an observation, a fact, as solid as any fact in science. You are related to every living thing, not metaphorically, literally, by descent, by shared ancestry, by the unbroken chain of reproduction stretching back billions of years. You are part of life, not separate from it, not above it, part of it. There's something deeply comforting about this, about knowing you're connected, related, part of an unbroken chain. You're not alone, you're not separate, you're woven into the fabric of life. Your existence is contingent on billions of ancestors, each one surviving, reproducing, passing something forward. And you're doing the same, even if you don't have children, even if you don't reproduce. You're still part of the flow, the continuation, the expression of life itself. You are not a static thing, you are a process, a pattern, a wave in the ocean of time. And when you die, the pattern will dissolve, the wave will merge back into the ocean, but the ocean continues, the process continues, life continues, and that's enough. That's beautiful, that's the only immortality that exists. Not individual, but collective, not personal, but universal. Let's talk about your brain, because it too has a history, an evolutionary history. And understanding that history helps explain why you think the way you do. The human brain isn't one thing, it's three things, layered on top of each other, like an archaeological site, each layer representing a different era, a different ancestor. Scientists sometimes describe this in simplified layers, and while the exact three-brain model is an oversimplification, the underlying idea is real. Different neural circuits evolved at different times, and they can prioritize different things. Some circuits are fast and survival focused, threat detection, reflexes, autonomic regulation. Others are emotion and learning heavy, attachment, reward, memory. Others support abstraction, language, planning, simulation of the future. And because they interact, you can experience internal conflict. You can know something logically while feeling something else emotionally, while your body reacts as if danger is present. That doesn't mean you're broken, it means you're ancient. The deepest layer is called the reptilian brain, the brainstem and cerebellum. This is ancient, shared with reptiles, shared with fish. It controls basic functions, breathing, heart rate, balance, reflexes. It's automatic, unconscious, essential, and it's been doing its job for hundreds of millions of years. Unchanged, reliable. On top of that is the limbic system, the mammalian brain. This appeared with early mammals about 200 million years ago. It handles emotions, memory, social bonding, motivation. It's why mammals care for their young, why they form attachments, why they play, why they feel fear, joy, sadness. And on top of that is the neocortex, the primate brain, especially developed in humans. This is the newest layer, the thinking brain, the reasoning brain. It handles language, abstract thought, planning, creativity, consciousness. These three layers don't always agree. They have different priorities, different goals, and that creates conflict, internal tension. Your reptilian brain wants immediate safety, food, reproduction. It's reactive, instinctive. Your mammalian brain wants comfort, connection, belonging. It's emotional, social. Your neocortex wants understanding, meaning, purpose. It's analytical, reflective, and sometimes they clash. You know, intellectually that something is safe, but you feel afraid because your reptilian brain is firing, overriding your neocortex. Or you know intellectually that you should do something, but you don't want to because your limbic system is resistant, uncomfortable. This is normal. This is the result of having multiple brain layers, each evolved at different times, for different purposes. You are not one mind. You are three minds, layered, interacting, sometimes cooperating, sometimes conflicting. And all three are ancient, inherited, built by ancestors who face different challenges than you face now. Your brain is adapted for the Pleistocene, for life as a hunter-gatherer, in small groups on the African savanna, not for modern cities, not for technology, not for the world you actually live in. So sometimes your brain misfires, gets confused, reacts to modern situations as if they were ancient threats. This isn't a flaw, it's just lag, evolutionary lag. The brain hasn't caught up. It takes thousands of generations for significant changes, and civilization is too new, too fast. Give it time, give it grace. Your brain is doing its best with tools designed for a different world. Here's the thing, you are not a blank slate. You are not pure potential. You are the product of history, deep history, evolutionary history. You have instincts, drives, fears, desires that don't always make sense in the modern world, but they made perfect sense in the environment where they evolved. You're afraid of snakes, even if you've never seen one, because your ancestors who were afraid of snakes survived. The ones who weren't didn't. You crave sugar, fat, salt, even though they're abundant now, because they were rare in the ancestral environment, and getting them was crucial for survival. You seek social approval, fear rejection, because in small hunter-gatherer bands, being cast out was a death sentence. These aren't choices, they're inheritances, installed by natural selection, refined over millions of years, and you can't just turn them off. You can understand them, manage them, choose how to respond, but you can't eliminate them because they're written into your DNA, into your neural architecture, into the structure of your brain. You are not just shaped by your personal history, your childhood, your experiences. You're also shaped by evolutionary history, by the experiences of every ancestor you've ever had. You carry their fears, their desires, their strategies for survival. And sometimes that's a burden, but it's also a gift because those instincts kept them alive. and they're keeping you alive too, even if you don't realize it. Here's something poetic. Some mammals returned to the water, went back to the ocean their ancestors had left 375 million years earlier. Whales did this. Dolphins, seals, sea otters, they descended from land mammals, but they readapted to aquatic life. Whales are particularly remarkable. They descended from small, hoofed mammals, related to hippos. About 50 million years ago, these mammals began spending more time in water, hunting fish, cooling off. Over millions of years, they became more aquatic. Their legs shortened, eventually disappeared. Their bodies became streamlined. Their nostrils migrated to the top of their heads, becoming blowholes. Today, whales are fully aquatic. They can't survive on land. They're born in water, die in water, never leave. But they still breathe air. They still have lungs. They still have the remnants of leg bones, tiny vestigial hip bones and femurs, buried deep in their bodies, serving no function, because they're mammals, descendants of land animals, who descended from amphibians, who descended from fish. They came full circle, left the water, adapted to land, then went back. And that's okay. Evolution doesn't care. It just responds to environment, to opportunity, to whatever works. If water is where the food is, if water is safer, if water offers advantages, then water is where you go. There's no shame in going back, no failure, just adaptation. And maybe that's a metaphor for life, for growth, for change. Sometimes you move forward, sometimes you circle back. Sometimes you return to things you thought you'd left behind. Not because you failed, but because that's where you need to be in that moment. Let yourself soften now. Let go of any tension you're holding in your jaw, your shoulders, your hands. There's nowhere you need to be, nothing you need to prove, no direction you have to move. You're allowed to rest, to circle back, to return to things that comfort you. Evolution doesn't judge, it just continues, moving in whatever direction works, and so can you. Everything changes. This is the lesson of evolution, the lesson of deep time. Nothing stays the same, not species, not bodies, not anything. The fish that left the water changed, became amphibians. The amphibians changed, became reptiles. The reptiles changed, became mammals. And the mammals are changing too, right now, including you. Evolution hasn't stopped. It's still happening. Slower than you can perceive, but happening. Humans are evolving. Our bodies are changing. Our genes are changing. In response to new environments, new diets, new challenges. Some populations have evolved lactose tolerance, the ability to digest milk as adults. This happened in the last few thousand years in populations that herded cattle. Other populations have evolved high-altitude adaptations, the ability to thrive in low-oxygen environments, like the Tibetan Plateau. These are recent changes, evolutionary changes, happening in real time, and more changes will come. Over thousands of years, millions, as environments shift, as challenges arise, as organisms adapt. What humans will look like in a million years, no one knows. We might be taller, shorter, darker, lighter. We might have different brains, different hands, or we might be gone, extinct, replaced by descendants, or by nothing. Evolution doesn't guarantee survival. Most species that have ever existed are extinct, over 99%, gone. Humans are not exempt. We're not special. We're subject to the same forces, the same pressures, the same randomness. We might survive, we might not. And evolution doesn't care. It just continues, with whoever's left. This is humbling, but also liberating, because it means the pressure is off. You're not responsible for the fate of the species. You're not responsible for evolution. You're just here, now, living as best you can. And that's enough. We think of ourselves as finished, as complete, the end product of evolution, the final form. But that's not true. We're just one step, one moment in an ongoing process. You are not the end point. You are the middle, the transition between what came before and what comes next. Your body is not perfect, not final. It's a work in progress, carrying remnants of the past, adaptations for environments that no longer exist, structures that don't quite fit. And that's okay. That's normal. That's how evolution works. Through imperfection, through compromise, through good enough. You don't have to be perfect. You were never supposed to be. You're supposed to be functional, adaptable, surviving. And you are, right now, in this moment. You are surviving, living, continuing the chain, and that's all you've ever needed to do. We've come a long way, from ancient fish in shrinking ponds to you, here, now, lying in comfort, breathing air, thinking thoughts. The journey took 375 million years, countless generations, endless transformations, impossible odds, and yet here you are, the latest expression, the current form, the living edge of an unbroken line. You are not separate from the fish that crawled onto land. You are their continuation, their descendant, their future. The bones in your arms were once fins. The air in your lungs was once gulped in desperation. The structure of your brain carries layers from reptiles, from mammals, from primates. You are an archive, a living fossil, containing multitudes, containing histories. And you are also new, unique, unrepeatable, because it's the specific combination of genes that makes you has never existed before and will never exist again. You are both ancient and brand new, both continuation and innovation. And when you die, your specific form will dissolve. But the pattern continues, the process continues, life continues. Your atoms will return to the earth, to the water, to the air. They'll be incorporated into other bodies, other lives, other forms. Nothing is lost. Nothing is wasted. Everything is recycled, reused, transformed. You came from the earth, from water, from ancient bodies, and you'll return. Complete the cycle. Close the loop. This is not sad. This is beautiful. This is how it's always been, how it will always be. Life eating life, life building life, life becoming life, an endless flow, an eternal transformation. And you are part of it, not separate, not special, not exempt. Feel the weight of your body, the pull of gravity, the earth beneath you, supporting you, holding you. You came from this earth, from the minerals in the rocks, the water in the oceans, the air in the atmosphere, and you'll return eventually, inevitably. Not as punishment, not as loss, but as transformation, as continuation. The same atoms that built you will build other things, other bodies, other lives. You are temporary. Your form is temporary, but the pattern is eternal. Life is eternal, and you are life. You've always been life. You'll always be life, just in different forms. So where is home? For the fish, home was water. For the amphibians, home was the shore. For the reptiles, home was land. For the mammals, home was everywhere. And for you, where is home? Maybe home isn't a place. Maybe it's a process, a journey, a transformation. The fish that walked onto land wasn't leaving home. It was expanding home, making home bigger, more inclusive. And every generation since has done the same, expanding, adapting, making home wherever they went. You are at home in your body, even if your body is imperfect, even if it carries the scars of evolution, the inefficiencies, the compromises. You are at home on Earth, even if Earth is harsh, even if it challenges you, even if it's not the environment your ancestors evolved in. You are at home in time, even if time is brief, even if your individual existence is temporary, even if everything changes, because home isn't about permanence, it's about belonging, and you belong here, now, in this body, on this planet, in this moment. You are not lost. You are not wandering. You are exactly where you need to be. The long walk home isn't about returning to some original place, some pure beginning. It's about recognizing that you've always been home. That home has always been moving, changing, evolving. Home is the journey, the process, the transformation, and you are home right now. You've always been home. You'll always be home, because home is wherever life is, and you are life. And if you want one last image to carry into sleep, imagine that inside every cell of your body, the same basic chemistry is unfolding. Ion gradients, membrane potentials, molecular motors, proteins folding into shape. Millions of tiny processes. Quiet, automatic, unaware. You are not holding yourself together consciously. You never have. Your heart beats because cells know how. Your lungs breathe because neurons coordinate rhythm. Your bones remodel because biology responds to stress and repair. Your immune system patrols because ancient rules are running in microscopic silence. You are alive because life has been practicing for billions of years. So you don't have to force anything tonight. You don't have to sleep correctly. You can simply allow your nervous system to shift state, to downshift, to drift. The same body that learned to breathe air will know how to rest in it. Imagine being a fish, living your entire life underwater, and then one day the water starts to disappear. And you have two choices: stay and die, or try something impossible. Your ancestors chose the impossible. They crawled onto land, they breathed air, they became something new. And every generation since has continued that choice, continued the transformation, continued becoming, until finally, impossibly, miraculously, they became you. This wasn't inevitable, it wasn't planned, it wasn't destined, it was chance, luck, the accumulation of small changes over vast time, survival against impossible odds, and yet here you are, the latest expression of that ancient lineage, that unbroken chain. You are the impossible made real. The fish that walked, the amphibian that breathed, the reptile that cared, the mammal that thought. You are all of them, and none of them. Something new, something new, something continuous. You are the journey from water to land, from past to present, from ancestor to descendant. You are the long walk home, and you are home. Good night. Let everything go now. The story, the history, the journey. Let it all fade into the background. You don't need to remember any of this. You don't need to hold on to it. It's already in you, in your bones, in your DNA, in the structure of your body. You don't need to know it. You just need to be it, and you already are. So rest, sleep, let consciousness fade, let the mind quiet. You are supported by millions of years, by billions of ancestors, by the unbroken chain of life. And tomorrow when you wake, you'll continue the journey, the transformation, the long walk, not towards some distant goal, but simply forward into whatever comes next, as life has always done, as life will always do, one step at a time. Good night, sleep well, the journey continues, always, but for now, rest, you've earned it.